enjoy learning. Today I would like to explain what do acids have in common and what do bases have in common by an activity. Let us see that first we have to prepare dilute HCl solution. Add slowly the acid to water and while stirring continuously. In the same way, prepare dilute sulfuric acid solution H2SO4 sulfuric acid solution in the same way as, and make glucose solution in another test tube and alcohol solution, and keep pure water, that is distilled water, in a small beaker, and sodium hydroxide, this is alkali solution, sodium hydroxide NaOH, and calcium hydroxide, that is lime water. First prepare these seven types of solutions. This is purely distilled water. Glucose, that is C6H12O6. Alcohol solution, that is C2H5OH. Pure water, that is the formula of that pure water is H2O. This is sodium hydroxide, this is calcium hydroxide. Go to the next slide. Look at the diagram first and how to set the apparatus. I read out and explain. Fix two graphite rods. Here is graphite rods. These two are graphite rods. Fix these two graphite rods on a rubber cork and place in this beaker, 100 ml beaker. Connect two different colored electric wires. This is one wire and this is another wire, separately as shown in figure. Connect free ends to the 230 volts AC plug and complete the circuit shown in the figure by connecting a bulb. Connecting a bulb to one of the wires. This is the setup of apparatus. Now the procedure, how to do the activity is, now pour some dilute HCl, already we prepared this solution in this beaker, and switch on the current. Whether the bulb glows or not, observe. So acid solution, that is HCl solution, conducts electricity. So the bulb glows here. The same experiment with dilute H2SO4 solution gives the same result. Next slide. First, glucose solution. Take the glucose solution and in the apparatus pour glucose solution and switch on. What do we get? What do we observe is glucose solution doesn't conduct electricity. Because of that, the bulb didn't glow. Next slide. Prepare the NaOH solution. Previously, just pour the sodium hydroxide solution in the beaker and switch on the current. The bulb glows. The bulb glows. Our conclusion is that we notice that the bulb glows only in acids and alkali solutions because the presence of H plus ions and OH minus ions in these solutions. But the bulb didn't glow in glucose solution, alcohol solution and pure waters doesn't glow. So, the reason is the absence of H plus ions in these solutions, glucose, alcohol and pure water. So, by these three types, HCl acids conduct electricity because H plus ions produce. Here pure water H2O doesn't conduct electricity because ions doesn't form. This is glucose solution doesn't conduct because ions doesn't form in that solution. In the same way, C2H5OH, that is alcohol, doesn't conduct, so ions does not form because in sodium hydroxide OH minus ions are there, so that electricity conduct in this solution. So, acidic solutions and basic solutions, those are alkalis, conduct electricity. This is pure water, glucose and alcohol doesn't conduct electricity. Conclusion about the acids. The positive ion, that is cation, present in HCl solution is H plus. This suggests that acids produce hydrogen ions in solution which are responsible for their acidic properties. The acidity of acids is attributed to the H plus ions produced by them in the solution.